Okay, what's the difference between speed and velocity? Both of these cars have the same speed, which is 50 meters per second, except one of them is going the opposite direction. So it's actually minus 50 meters per second when it comes to velocity, because the minus shows that it's going in the opposite direction. Normally we define left as negative and right as positive. The definition of speed and velocity is speed is the rate of change of distance, and velocity is the rate of change of displacement, because velocity is a vector. The equation that you'd use, the word rate means how much per unit time. So for example, the rate at which this car moves, it moves 5 meters every second. It's how much per, or you can say every hour if you wanted, is how much per unit time. So you normally find time at the bottom of the equation dividing the thing at the top. Okay, so the equation here is velocity equals displacement over time. We use the symbol S for displacement now, and this equation here should only be used for things that are moving at constant speed or constant velocity. So for example, if it's constantly moving at 5 meters per second or minus 5 meters per second, it's not changing that speed. If anything is accelerating or decelerating, you should not be using this equation if it's accelerating or decelerating. Okay. When it comes to acceleration, you should be using a couple other equations, which one of them being this one, which is definition. Acceleration is how the rate at which the velocity changes. So it's how much the meters per second, how it increases every second. So it's your change in speed divided by the time it takes. For example, you might have when something falls, it falls at approximately speed increases at a rate of 10 meters per second squared. So that's the acceleration. So every second its speed increases. So if you start off at 0 meters per second, after 1 second you'll be moving at 10 meters per second. After another second your speed will increase more to 20 meters per second, and so on. So that shows acceleration. If it was negative, that would represent deceleration. Okay, so we're going to have this person riding a bike. He accelerates at a rate from rest at a rate of 0.08 meters per second squared. If he does this for 1 minute, what is his final velocity? So we know he's accelerating, so we have to use the second equation we looked at. And how you set that up is you write S, U, V, A, T. Okay, so each one representing displacement, and then initial speed, final speed, acceleration and time. So his acceleration, it says 0.08 meters per second squared. His what we're looking for, we've got his time 1 minute, but that's not the right unit, so we're going to turn that into seconds. And then we have another piece of information which is not clear to see. It says start from rest. That means his initial velocity is 0, and it's asking for its final velocity. That's what we want to find, question mark. So the equation we need to use is A equals V minus U over T. If we put the numbers in, you get 0.08 equals V, which we don't know, minus 0 over 60 seconds. If we rearrange it, 0.08 times 60 equals V minus 0, but minus 0 doesn't mean anything, so you can just ignore the minus 0. So this gives us 4.8 meters per second. Now the second part B, he continues at this speed for 2 hours. Calculate the distance traveled in this time. So now he's moving at constant speed, because it says he continues at this speed. That's actually referring to the speed from the first part of the question, because it's the same question, it's part B of the question, so you can use the number from the previous question in the second part. So he's continuing at this speed, so we can't use the acceleration equation. We have to use velocity equals displacement over time, or distance over time, and the time is 2 hours, which we need to turn into seconds. So that's 2 hours, there's 60 minutes in an hour, and there's 60 seconds in every minute, so that's 7,200 seconds. If we put these numbers in, we get 4.8 equals displacement over 7,200, and rearrange this gives us two similar figures. Okay, the man hits the brake. It took him 1.5 seconds to come to a rest, calculate the acceleration. So now we need to go back to using the acceleration equations, because we can't use a constant speed because he's slowing down. We can't use the acceleration questions because and the constant speed one because he's slowing down. Okay, so this part here, what do we have? So his initial his speed starting off is actually moving at the same speed as before, so it's still 4.8 because that hasn't changed. And then his final speed, he's slowed down and he's come to a rest, so it means he's stopped. His time is 1.5 seconds, and acceleration is what we're trying to find. A equals v minus u over t. If we put this in, we get 0 minus 4.8 over 1.5, and if you put that number in, you get minus 3.2 meters per second squared. This means he's decelerating, he's slowing down.